Hi everyone. So today we are going to learn about the SQL data types. If you remember from the yesterday's class, we talked about we created the basic table and then also we talked about the different properties that a table can hold. We talked about the different type of constants that are there in SQL Server. Now with once we complete the SQL data types, basically with that, we'll actually start the actual SQL classes because right now we are just building up base and all for all the things that we are going to do in the future. So let's learn about the different data types. Data type is an attribute that specifies type of data of any object. Each column, variable, and expression has a related data type in SQL. Basically, whatever object that we define in SQL Server, that that would come with a data type, whether it's column, whether it's variable, or whether it's expression. When we talk about the categories of data type, there are various categories of data type in SQL Server. The first one is the exact numeric data type. Then we have the approximate numeric data type. We also have the date and time data type. Then we have the character string data type, the Unicode character string data type, and the binary data type. So these are the major categories of the data type. Inside each of these categories, we'll find different types of data type depending upon the size and the domain. We have to select a particular data type for each of the column that we are defining in SQL Server or each of the variable that we are defining. Now let's talk about each one of them. Don't get uh, don't get confused and don't get those things that you have to remember all of this. You don't need to remember anything what is there in the screen right now. This all will come to you with experience and all. Even I don't remember any of this data type size, like what is the size of begin. If someone asks me, I'm not able to tell because again, it's not important to remember all this. But again, with experience, when you start working on SQL Server, you'll actually get that thing that in which scenario you should be using which type of particular data type. So just understand that in which category we have a particular data type. When we go for the exact numeric data type, we have the big int, we have the int, we have the small int, we have the tiny int, we have the bit, then we have the decimal, numeric, money, and small money. These are the data types that comes into this exact numeric data type category. And then after that, we have the size of each one of them. I can forward you all these details through a notes, right? If you want to go through it in detail. But again, from my side, that is not required. Excuse me. Basically, what you need here is that just to understand on a high level, the major limit of each of these data type. Like in a normal scenario, uh, int is sufficient to hold even even tens of millions of records, right? And if you suppose that if you need more than that, then that is the case when you'd be using big int and all. But normally, when we define our data types in SQL Server, we either use int, a small int. That is what we use the maximum. Tiny int is, again has a very less domain. That means it start from 0 and end at 255. So definitely that is very less. And there are only few places where we use that. Then bit is used for anything where you have to set a flag. That means it's either true or false. Then for that you can use the bit. Decimal, numeric, money, small money, these are used for anything which has data after the dot. That means it has, for example, if you want to store 100.50, that is the place where you can use decimal, numeric, and all of that. When we go for the approximate numeric data type, then we have the float and real because they talk about approximity, right? They are not something which is actually talk about the actual size, but they talk about the approximate size, and that's why they are known as approximate numeric data type. The major thing that I want you to learn, or the takeaway from this class, is understanding the difference between where and where care and care. So we'll talk about that soon. Then we have the date time, small date time, date and time. These are the four data types related to the date and time data type. One of the major thing here is that for the date time, we have the date starting from Jan 1, 1753. So if you want to store any date, suppose that you want to store the year 1011 in SQL Server. How do you do that? Because the date time actually starts from Jan 1, 1753. Now, MySQL, suppose that you have the background of MySQL. MySQL allows you to store any values in the date, but SQL Server allows you to store from this date, right? So, if you want to store something which is not allowed as per that data type, what you can do, you can convert that column into a varchar, and then you can store whatever you want, right? So that are some of the things that we do. But normally when you will get a real-time requirement, definitely the date Jan 1, 1753, again it covers a lot of domain. So definitely that is something that you not actually need in the normal scenario, that you won't need to use the varchar instead of using the date time there. But again, that is a flexibility that we can have. Then if we go for the characteristic data type, then we have the char, varchar, varchar max, and text. Talking about the char has the maximum length of 8,000 characters. In the same way, the varchar has the maximum length of 8,000 characters, right? And then we have the varchar max. Now, varchar max, it actually it doesn't talks about the character. It actually is dependent on the size, and with the version, this changes. For the newest version, it is close to maybe 2 GB. Then we have the text data type. So something which is very large in size, which can't be stored by the varchar also. Then for that we use text. There are some cons of using text data type as well. One of the major cons is that you can't create indexes, normal indexes on the text columns. So that means this text column would create an impact on your queries. That means that your queries would run slower when you have the text columns involved in the query. So don't use text column just like that. Always prefer to use varchar when you are using the characteristic data type. And if you know the size of that, then you should be using char. Similarly, we have the Unicode characteristic data type. So what is the difference between uh, Unicode and the normal characteristic data type? The difference here is the language thing and the size. So for example, the maximum size for the varchar was 8,000. In the same way, the maximum size of n varchar is 4,000. Now, why we have that difference? Because what happens with Unicode is that, for example, you are using the French language and you want to store French language inside SQL Server. Then in that case, if you have some special requirement, if you have got to store special characters inside the character string, then you have to use the Unicode character string, because Unicode character string is used for handling special requirement related to the language and all. So anything where you need special handling, that means maybe it's something other than English, you want to store German, any other language, then in that case you'd be using the Unicode character string. And the only con of you storing the Unicode characteristic, that it will require double of space, because it contains two things. One is the data, and second is the uh, pointer to mark, okay, what is the Unicode specific thing for the data, right? So it would require double the space. So that's why don't use n varchar just like that. If you don't need any special language handling, then we should not be using n varchar or nchar and things like that. Normally we should be always using varchar and char and varchar max, right? But if we have something special characters are required to be entered in that data, then only will we go for n varchar, nchar, and n varchar. Last but not the least, we have the binary data type as well, which is used for storing the binary data, which is a machine understandable data, right? So for that, we have two. One is the binary, which is similar to char, and then var binary, which is similar to varchar. So again, var binary means variable length binary data, and the binary means fixed length binary data. Both of them have the maximum length of 8,000 bytes. We don't need to focus a lot on what is the maximum size and all of that. What we need to just understand is the major differences here, that in which scenario you should be using which data type, and that again it will come as soon as you start doing practices on whatever you are learning and all, right? So let's go and let's do some practice on the data type and all. I'll maybe we'll start with some questions and we'll try to see that what is the particular data type that we should be using a particular scenario. So I'll just switch my database to the bash 266. Here I'll also tell you that how can we switch the databases. So this is one way. If you see, we have a drop down here. Through this way you can actually switch the database, right? The other way is that you can also use the use statement. So use batch 266. If you use that and if you execute, that will also switch the database. For example, if I want to go to some other database, I can do that. You can see that my database got changed. So I'll again switch over to batch 266 and this is done. Now, the next thing is that I want to create a table, and I want to be very specific about the data types that I want to have for each of these columns. So for example, let me create a table named customer history, right? So here I will store information about the customer, like what are the, so the first thing that I want to keep here is the customer ID. Whenever we store ID like values, right? So what we try to do is that we try to store all the IDs in the integer, right? And again, this customer table can grow. It can have any number of characters because a customer is definitely a transactional table. Again, what is a transactional table? So let me talk about that as well. Basically, when you have the database, right, you have two types of tables in a particular database. One is the master table and second is the transaction table. What is the difference between the master table and the transaction table? So when we talk about the customer table, customer is the master table because that will store all your customer information, right? The customer history, it can either be master table or the transaction table. It can be also, you can say it is a mapping table, that which is the third type of table there. So a customer places order and all, right? So order can be a transaction table. Order for sure is a transaction table, right? The customer can be a master table while the order can be a transaction table. There are some tables which are just used for mapping of data. For example, suppose that you have a gender table, right, where you are storing the gender and all. So that is a master table, right? Then you have some other table where you are using these gender values in the form of IDs and all. That would become the transaction table. There are some tables where you use both the IDs together to just take care of the transactions and all, and that is known as the mapping table. So when we talk about the customer history table, this comes to a situation where if you are storing, suppose for each customer, you are storing multiple records, then that would become a either a this would become a transaction table because again we have multiple records for each of the customer, right? If we have just one record for each customer, then that would become a master table. I hope this is clear to everyone. So the first column that I have written here is the customer ID, then maybe I'll write the customer name, right? Now, what should be the size of the customer name, whether it should be char, varchar, and varchar, and what, right? So, because here the requirement is just that we have to write in plain English, we are going to go with the default uh, language of the SQL Server here. So, for this column, I'd be just using varchar, right? So what would be the maximum size? So this I have kept 30. What it means here is that 30 is going to be the maximum size of the customer name, right? So if you try to insert some customer name of size more than 30, this should not be allowed by SQL Server, right? So you have to mindful of what is the size you are selecting, and that size doesn't comes automatically. It comes by the requirement. So whenever you'll get the requirement and when you'll analyze the data, from there you'll get the understanding whether you should be keeping this 30, you should be keeping this 50 or 100, right? So that will come from there. Now, uh, places list. Now this is again something which is connecting string data. So I'll again keep it as varchar. Then current address. Again, this is varchar 100. Past address, varchar 100. Number of items purchased in, right? Suppose that I've defined this table as of now. I've not created any primary key on this table. That is intentional. Okay. We can definitely create all of that, but right now the focus is not that. The focus is just to right now create a table and use the appropriate data type intentionally for one of the one of the column, though I have kept the data type as something, but that can definitely be changed, right? Can anybody tell me which of the column we can change the data to something more appropriate just by looking into the business logic here? Anyone has any idea? Like which column? Like right now we have 1, 2, 3, 4, 5, 6 columns in this table, right? The customer ID, which can actually, there can be many customer for a particular thing, whatever we are using. Maybe we are trying to create a customer details of Amazon and all. So maybe even for them, int would not be sufficient. Maybe I'll need to change it to begin in that case, right? So that can be one thing that we can change. Now the customer name again, varchar 50, that is, I think it should be sufficient for most of the customer if we want to store the name and all. Places lived, that can be again, that is fine with varchar 100. Current address again, that is also fine. This is also fine. Number of items purchased. How many items can a customer purchase? Maybe someone can shop 100 items, someone can shop 1,000, maybe 10,000, and something like that. So I think here, so as per the limit of the small int, which is again in the terms of hundreds, it's not like in the terms of the maximum size of the small int. I think it's 32768. That is the maximum size that you can store for that, and I think that it should be sufficient for this column, because again, for a particular person, for a particular customer, you can actually store the maximum number of items, uh, or a particular customer can purchase. It can be either 1,000, 5,000, something like that, right? So we can definitely change this particular thing to small int. And now I can create this table. So once I created that table, now at some point of time, definitely it may be like that we see that okay, we have created this table with this column size, but I think we need to change the data type of that. So we can do that at any point of time. Once we started entering the data and we find that okay, this is not sufficient, right? I want to change this to n. So for that, we use the alter statement. Now here I'm introducing you to the alter statement, which is the next thing. So alter table, then you use the table name, which is the customer history here, right? Alter column, then name of the column, then data type of the column, right? So if I run this statement, now you can see that this got succeeded, and I have changed this number of item purchased from small int to the int here, right? I can just go into the database and I can see that as well. I'll go to batch 66 tables, and then I can go to the customer history. In the columns, I can see that the number of items purchased, it's now integer. While I had developed it as a small int, right now it's integer. Any questions so far? Right. So with that, we are coming to our start of the querying thing and all. Though I have already created few tables with you, but officially now we are going to start creating the tables and all, right? So the create table is one of the most important query, I would say, that we need to learn, and that is where we start with the base of SQL Server. That means starting the query part and all. So talking about that, again, if you remember, just two classes back, we talked about the different type of languages that is supported by SQL. So we have the DDL, that means the data definition language. Then we have the DQL, data query language. Then we have the DML, data manipulation language, and then we have the DCL, data control language. Create table is actually a data definition language command. Why? Because this is used to define the data. So, and through this create table statement, we define the table structure and all. So that's why it's a DTL command. The syntax of the create table looks like this. So you write create table, then your table name. After that, you start the bracket, and then you mention the column names and the data type of each of the columns. So this is the basic structure of the creating the table. Now, if you want to add the constants as well, like for example, the primary key constants, etc., you can do that, right? By putting up in the end, like I have already done that, but I'll again show you how to add the constants also while you are defining the table. But suppose that if you have actually created the table, and after creating the table, if you want to add the columns to the existing table, that is also can be done. So anything can be done after defining the table as well. So don't think that once you created the table, after that you can't do any changes in the table. You can do all the changes, like you can drop the constraint, you can add the columns, you can change the data type of existing column and things like that. So how do you check whether a particular table exists or not? There are many ways of checking that. One of the ways is that you use select star from sentence, that means select star from schema name dot your table name. So with that statement, you can actually check whether a particular table exists or not. Or you can go to the um, previewer here in the SSMS, and there also you can just check whether that table exists or not. Like I have checked here that we have the customer history, right? Then comes the adding column to existing table. If you want to add column to existing table, you use the alter table statement. So what you use here is that alter table table name, and then after that add column name and data type. This is what you use to add a column to existing table, right? For example, you created a table with 5 different columns and you want to add 2 more columns. So in that case, you have the either two things. Either if it's a very new table, what you can do is that you can drop the table and you can create again the table with adding those 2 columns. But that is only possible in the those table which you are trying to actually start from scratch, which we are trying to define just now. But what if some table it has been existing there since long time and you want to insert some or add some column to the existing table? So for that you use this particular statement, that means alter table table name and then add column name data type. This is just about adding the column. Sometimes we need to drop the columns as well from the table. So for that also we use the same alter statement. That means alter table table name, drop column column name. This is used to drop the column from the table. Let me do that also for you. So for example, the same customer history table, suppose that I want to, first of all, we have learned two things here. First is that adding the column to the table. So that is what I'm going to do now. So what I'll do is that alter table table name, add column name and the data type. So as you can see, alter table name. Then after that, I'll use add, right? Suppose that I want to use uh, gender. And what is the data type I want to keep? Maybe char 10. This is the data type I want to use for this, right? So with this, I can add a new column inside this table. So as you can see, the command completed successfully. Now this column is added uh, into this table. Now, if I go there and if I see here, I don't see that column here. Can anybody tell me why this is like this? Why I can't see that column here in this side in the
You
management
have
studio?
you have to like again select view, view it again, right? Like select star from table
No,
again to view it.
no, okay. To view it here, that's what you are saying,
You have to refresh it.
right? So
Refresh.
basically, that's correct. We need to refresh. So because as of now, what I have done is that I have just added the column, but what view you are seeing here, whatever view that you are seeing here, that is actually that comes at the time you actually open it. So right now I opened it like just some time back, and then after that I added this column. So if I want to see my latest changes, I have to go to click on this table. I have to go on this table and right click, and there's a refresh button here. Once I click on refresh and then I go to columns, you'll see that we have the gender column, right? So this is how you can see the changes. Sometimes we get confused, okay, why I did this change, but I can't see that here. So this is the reason, because you have not refreshed the latest version and all, right? If you are doing changes in multiple objects together, you can just refresh the database. That will refresh everything in the database, right? So this is how we refresh the database, and then you can go and you can select the tables from. So this is about adding column to existing table. What about dropping a column? So let's do that as well. So for that, we have the same alter table, table name, customer history, drop column, and the name of column. Maybe let's remove this column. So you can see I got this message that command completed successfully, right? So, but now I can see it here, so I can just refresh it again. So you can see that we don't have that column now. We don't have the places lived column now here. So this is how we drop the column. Creating table from another table. This is a very interesting thing, because many times what we do is that we we just try to create a clone of the table, right? So one of the easiest way of doing that is using the select star into statement, right? So when you use select star into, then name of the new table from the old table, right? If you use this statement, what will happen is that the new table would be created, and also the data from the old table would all be copied into your new table, right? this is these are the two things that happens whenever you create table from another table. For example, I have this table, right? It doesn't have any data right now, but that is fine. If suppose that it has 100 of record, right, and I want to create a copy of this table in the same database, right? So in that case, I can use this select star into statement. So what I'll use is that select star into, and maybe I'll use it a keyword customer history underscore new, and then after that the from keyword, and then the customer history, right? And when I'll do this will create a new table with the name this customer history underscore new. It will contain the same columns as we have in the customer history table, and it will also copy all the data from the customer history table to this table. Right now we don't have any data in this table, and that's why if you see here we got this message zero record or zero rows affected. That means that we don't have any data, right? So that's why it's coming at zero. Otherwise, if we had suppose that 100 records in this one, similarly 100 records would be created in this one. So this is a way of copying the table content from one table to another, and also creating the structure of the table at the same time. Now, one thing that I want to understand from you guys is that I hope that you understand that why I'm not using here like everything with the DBO dot table name and things like that. Why I'm not using that all of that, because by default my schema is DBO, right? And that's why everything that I'm doing is getting created in the DBO schema. Even if I don't give like from which schema I want, so it will always pick up from the default schema. If you have multiple schema in place, always try to use the object name with the schema notice. And how to do that? That means whenever you are using, for example, alter table, then use schema name dot table name. That way it will bring more clarity to the statement that you are running. And sometimes suppose that, as I had shown yesterday, that you can have the same customer table in two different schema in the database, right? So which particular customer table you want to update, from this schema or the other schema, right? So that's why, to have better clarity and to avoid confusion and to avoid any errors while doing the statements and all, always try to use the schema name dot table name if you have multiple schemas in place. If there's just one schema that you are using, then in that case you don't have to worry about all of that. Now the other question that can come here is that we talked a lot about schema and all. How do we create a new schema in the database? So for creating a new schema, we use the create schema syntax. That means create schema and then name of the schema. Maybe I'll give this a name, batch 266. And what I'm going to do is that I'm going to copy this table from this table. Let's see what happens. You can see that this table is also created. Now let me refresh this database to just see the different type of tables that we have. You can see that we have the same table customer history in new underscore new in the DBO schema, as well as it is in the batch 266 schema which we just created, right? What we did just now is that we created a new schema batch 266, and then we created this new table with the name customer history underscore new, right, in this same schema. And what we did for creating this, we copied the content from the DBO dot customer history, right? So if you have multiple schema in place, you should be just using the schema dot notation. That means the schema name dot table name to do anything that you are doing. So right now in my database, I have two schemas in place. One is the DBO, which is the default schema. So suppose that now I have multiple schema here, right? Now suppose that I just do this create table statement, create table, then maybe mapping data, and then data ID and data value back at 10. So if I do this, right, here I have not mentioned that in which schema this table should get created. Can anybody tell me in which schema they should get created? I've already talked about it hundred of times. I expect that everyone knows that in which schema they should get created. No one knows in which schema this table would get created. Guys, if you are not understanding,
It,
please,
like
yeah,
it's the DBO itself, right? Because we have already selected. That's a default one. You didn't select
right,
anything else.
right. That's correct. So because we have not changed the schema, so it would be always be the default one, that is the DBO schema. where it would get created, right? But if I change the default schema from DBO to bash 266, in that case it
Yeah,
would get created to in the bash
batch
266. Yeah.
2266. Yeah.
Now the thing here is that because we have multiple schema in place, so I should not be using queries like this, because again, because there is a confusion. So that's why I asked this question, whether you guys are confused or you guys are okay with this, right? So always, to make sure that and to avoid confusion, always use the schema name dot table name when you are defining anything, right? Or when you are using the table in the select queries, or you are creating the table, or doing anything with the table. Always try to use the schema notation. That means the schema name dot table name. Now it's very clear to everyone now that this table would get created in the DBO schema. But anyhow, if that is optional, if I don't use that, then in that case also it get created in the DBO schema. So right now this table got created right in the DBO schema. Now let's go and let's talk about one of the most important thing, which is related to designing the database, right? When you start working on the database from the very beginning, and here I'm talking about the OLTP system, right? So let me go and let me talk also about the OLTP and the OLAP system, right? OLTP and OLAP. These are the two different type of solutions that Microsoft provides in terms of uh, databases, right? So I have already talked about that in one of the previous classes, but let me again go back there and let me talk about that. So OLTP means online transactional processing. So basically, if you, let's consider again the Amazon shopping portal as one of our reference products, right? So anything that you do shopping from the databases, shopping from any of the shopping applications like Amazon and all, right? They have a lot of products, and each of these products have prices. Then you as a customer go and you purchase the product and you create your cart and things like that, right? So all that thing, all that transaction that is happening, that happens inside the database, right? And when that thing transaction happens in real time, that is, that solution is known as the OLTP database solution. So if anything that is happening in real time, right, that is the OLTP solution that is happening, or anything which is attached to your front end application. That means anything that is attached to your UI part, that is known as the OLTP application. Now we have another solution, which is the OLAP in solution, which is actually used for analysis, or this is known as online analytical processing. What does it mean is that, for example, now the customer has purchased uh, X number of items. Many customer have purchased. Now this shopping website, just for their future reference and all, what they do is that whatever the data that, or whatever the transaction that has been made, on basis of that, we create different type of schema in place, right? We create different data, which is known as different database, which is known as data warehouse, right? So whenever you hear the term data warehouse, there we are talking about OLAP, that means online analytical processing. That means this all companies, what they do is that they have a separate environment which has similar data as for the OLAP, but the way the data is stored is differently. And through that data, they try to analyze about the past, and they try to make future decisions. For example, suppose that Amazon has around 100 products, right? But what they are seeing is that the customer is buying only 3 4 products, like 3 4 products customer are buying in millions of quantities, while other product they are just buying like in hundreds or thousands, right? So then for Amazon it doesn't make sense to have all these products in the same amount, right? All these products should not be in the same amount, because some of the products they are being highly purchased, while some of the products people are not purchasing. So how to make that business decision? Definitely by looking into the data, we can make those decisions. So that's why we have this separate environment OLAP, where you just create your reporting, your Power BI report, your SSIS data, that actually take SSIS packages or the EDL packages that brings up the data from OLTP to OLAP, and it converts it into facts and dimensions, or the star schema and the snowflake schema.
So these are all things you are going to learn in future in the BI classes and all, right? So there you'd understand, okay, this is where we are talking about the OLAP environment and why this is important, right? If we don't have that data to support like the thing, that then Amazon would be in huge loss, or any such shopping website, right? Suppose that the customer likes to buy laptop a lot, then it doesn't make for Amazon to keep uh, millions of laptops and then millions of computers as well, because again the desktop people are not buying. And that then that we can tell just by looking into the historical data, that people are just looking to buy laptop. So what I do is that I'll keep laptop as millions, but I'll keep the desktop at just hundreds, because only few customers are buying, right? So this is how we make the business decision on the basis of data, and that's why the OLAP is environment. But right now, our focus should be OLTP. Right now, we are trying to understand the OLTP system. And one of the most important thing that we need to learn to design a particular OLTP system is the normalization, or the database normalization, which we are going to learn now. So talking about the database normalization, normalization is a process of actually removing redundancy from the data. That means whenever you're defining the tables and all, you try to keep similar data together, and if the data is not similar, you break it into multiple tables. And this is what the normalization process is. So normalization is all about doing the data modeling for the OLTP system. So let's talk more about that. So normalization is a process of efficiently organizing data in the database. So here the most important thing is efficiently. That means you don't want to, you know, store the redundant data. You want to store the efficient data only. That means any data which is linked should be the same, should be in the same table. If data are not linked to each other, that should be in different table and things like that. Normalization eliminates redundant data. It ensures only related data is stored in a table, right? So talking about normalization, we have different types of normal forms. We have the first normal form, then the second normal form, then we have the third normal form, and then we have the BCNF. Then after that, we have fourth normal. In the real world scenario, in most of the companies, you will see the data up to second normal form, or at max the third normal form. Nobody goes after that, because as you go into normalization, the data set or your tables would become very complex, your queries would become complex and all. And that's why, and also normally in the normal business scenario, the data is not very simple, it's very complex, right? So that's why even if you go for second normal form, that should be sufficient for from the designing perspective, or at max you can go for third normal form. So as part of this learning, we are going to learn about second normal form. We'll focus about that. We'll focus on first normal form, second normal form, then definitely we'll touch base with the third normal form. But my expectation for you is that you are able to understand the first and the second normal form. I think that is sufficient, not only from the work perspective, but from the interview perspective as well. Now let's talk about the first normal form. A database is in first normal form if it satisfies the following conditions. Contains only atomic values, there is no repeating groups. So these are the two conditions for a database to be in the first normal form. So when we talk about the database, actually we are talking here about the tables in that database, right? So in a database, we can have hundreds of tables. And then we are talking about each of these tables, that the table should contain only atomic values, right? So what does it mean? We'll talk about that with example. And then there are no repeating groups. That means the same information should be not repeated in the same table. So we have to take care of that. Once we take care of both these statements, then we get a table in a first normal form. So let's see that with an example. Suppose that we have a table named table product, right? Here you can see that there are three columns. First is the product ID, second is the color, and third is the price. One of the things that you see here is that when you see the color for the product ID one, it has two colors. One is the red, comma green, right? We never store the data in such a way in a table. We don't store comma separated values, right? If we have multiple values, we try to separate it in form of different columns. or rows, depending upon the situation. So for example, for this situation, what we could have done is that for the color red, we could have one row. For the color green, we could have one row. But right now it's just two rows, and which is actually not a normal data. So when we were talking about atomic data, we were talking about that. That means in a combination of a column and row, there should be just one value. There should not be multiple values. So similarly for the product ID 4, you see that there are two colors, yellow and blue, which is again comma separated. It again doesn't make sense from the perspective of the first normal form. So this is something that we want to eliminate, and then our table would become the first normal form. So right now it's not in first normal form. So how to do that? There are multiple ways of doing that, right? And the best way of doing that is separating this out in a different two tables altogether. One table just to store the product and the price. That means for each product you see that there is a particular price. So product ID 1 price is 15.99. So what we can do is that we can separate out that in product price table, and then for the product color we can have different table altogether. So that means for each product, if there's two color, I'll just put up two different columns for that, right? I could have also done it in one table, but why we are not doing that? Because then again, this table would contain some redundant information. That means you'd be storing more data in that case. For the same product ID, you'd be repeating the price as well along with the color. So it's better to keep it in two different tables like we have done it right now. And now this table has become normalized up to first normal form. As of now, I don't know whether this is in second normal form or third normal form, but just understand from this perspective that this is the first normal form table, right? So this is the basic criteria for a table to become in the second normal form as well. That means the table should be in the first normal form. That is the first. So a database is in second normal form if it satisfies the following condition. The first condition is that it is in first normal form. And second condition is that all non-key attributes are fully functionally dependent on the primary key. Now, the first thing, I think it's clear to everyone, but what we are talking about in the second part, all non-key attributes are fully functionally dependent on the primary key. What does it means? It means that any non-key attribute is means here is that any column which is not part of the primary key, that is what is the non-key attribute. And they should be fully functionally dependent on the primary key. So let's see that with example. Let's suppose we have this particular table. This table has a composite primary key on the customer ID and the store ID, right? We can't have the customer ID as the primary key here. I hope everyone understands that why we can't have the customer ID as the primary key. Because if you see the same customer ID is there like 1, 1, then 2. So there's a duplicate value for the customer ID. 1 is there for 2 times, and that's why that can't be a primary key here. Similarly, for the store ID, if you see, we have the store ID 1, 2 times, then 3 also 2 times. So again, that column can't be a primary key column here. So what if we combine the customer ID and store ID? Do we get duplicates? If you see, we don't get duplicate in that case. So that means that the customer ID one and the store ID, that becomes a unique thing. So we have a composite primary key here, and that is on the customer ID and store ID. Now this table is already in first normal form. Why? Because you can see that there's no you don't see two different values for a combination of row and column, like we had that comma separated value in the last one, right? Other than that, also we don't have the duplicate information across the table. That means we are not repeating the same row again in anywhere, right? So if they are these two things are matching, so that's why this table is already in the first normal form, which is the basic requirement for a table to become into the second normal form. Now, when that is there, the second thing that we want to see here is that what is the non-key attribute here? So non-key attribute is something which is not part of the primary key. So here we have the non-key attribute as purchase location, right? Purchase location is not part of the primary key. So in this case, purchase location only depends on the store ID. If you see, for the store ID 1, purchase location is Los Angeles. For the store ID 2, purchase location is New York. For the store ID 3, purchase location is San Francisco. Can we see if there is a dependency between customer ID and purchase location? For the same customer ID 1, we have two different purchase locations, right? So that means this purchase location column is directly dependent on the store ID only. But what is the rule for the for the for the table to be in the second normal form? One of the other rule is that all non-key attributes. So the non-key attribute here is the purchase location. Should be fully functionally dependent on the primary key. What is the primary key here? Customer ID plus store ID. But the purchase location is only dependent on the store ID. It is not dependent on the customer ID. So it doesn't make sense. This table is not in the second normal form. So what is the best way of converting this table to the second normal form? What we can do here, we can create a different table, like two tables in all together. In one table, we can store the purchase location and the store ID, while in the other table, we can store the customer ID and the store ID. So let's see that. So this is what we have done. And this is, as of now, what you see now is that the table is optimized also. While in the other example, you were seeing that the purchase location was repeating and all, right? In this example, now that information is not repeating and all, right? And now this table is in second normal form, because if we talk about this, the first table purchase, we can have the composite key again there on the customer ID and store ID, while in the table store we can have the primary key on just the store ID. And that's how it is, and that's how we can say that this table are in second normal form. So let's talk about the other normal form, which is the third normal form here, right? We have already talked about the first normal form, the second normal form. Now for the third normal form, the main criteria here is that the table should be in the second normal form, right? That is what should be there. So if that is satisfied, then only we can go for the third normal form. So once we see that okay, the table is in second normal form, then the next step here is that there should be no transitive functional dependency. What does it mean? So let's see that with example, what is a transitive functional dependency? So again, we have a table here, table book detail. In this table, book ID determines genre ID. If you see, for each, we have a unique book ID here for each of the column. Using the book ID, we get the genre ID. From the genre ID, we get the genre type, right? So we have a transitive functional dependency. What is transitive functional dependency here is that, for example, A is to B. This is a concept of mathematics. So B is to C. Then we say that A is to C. If we have something like A is to B and B is to C, then we say A is to C. This is known as transitive dependency. And we should not have such dependency in a database table for it to be in the third normal form, right? So the book ID is actually deriving the genre ID. The genre ID is actually deriving the genre type. And that's how A is to B is to C. That means A is to C. So we have this transitive dependency, and that's why this doesn't satisfy to be the third normal form. Though this table is already in first normal form and second normal form, first normal form you can directly see. For the second normal form, you can just keep the book ID as the primary key here, because that is having the unique key. And then in that case, you will see that there's no the non-key attributes are fully functionally dependent on the primary key, right? Now the thing here is that we have a transitive dependency, which if we are able to eliminate, then we'll get this table into this third normal form. So in order to get that, definitely two columns which are interlinked here is the genre ID and the genre type. What I would do is that I'll keep that as a separate table. I'll remove those records as a separate table. So then I'll create two tables, one with the book ID, genre ID and price, second with the genre ID and genre type. And that's what we are going to do. And this is what has become here. So now this table is in third normal form because we don't have that such dependency now. In the first table, if you see, this book ID is deriving genre ID, but again book ID is again deriving the price as well, right? In the second one, this genre ID is deriving this genre type. So this is the example of the third normal form. Any questions here about any of the normal forms? Is it all clear or nothing clear?
Clear.
Yeah, Chris, do you want to ask any question, or is it
No, it's
clear to you?
clear. No, it's clear.
Okay, 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 that's good. So now from now onwards, whenever we'll design a database, or I'll give you some assignments as well. I'll start those assignments maybe after tomorrow's class, right? Then there, whenever you are designing the tables and all, always think from the normalization perspective as well, that what are the columns you are using in one table, then when you are going to different table, because this is just a basic of what I have covered so far. The advanced level of this normalization will come into picture once you actually go and focus on these things when you are designing the data. So what you have to remember here is that, so it's very simple. For the first normal form, there should be just atomic values. There should not be repeating rows, right? These are the two rules. So if you see that just in first glance, you'll understand, okay, this is already in first normal form. For the second normal form, all non-key attributes should be fully functionally dependent on the primary key. Now, mostly the tables are in second normal form. Only the condition where we have composite key, there can be a issue where you'll need to convert that into multiple tables and all, but normally it should be like that only, right? So that is also resolved here. Now, for the third normal form, definitely we need to have the table in the second normal form, and there should be no transitive dependency. So if we just see that we have a transitive dependency, we can eliminate that by breaking up the table into two parts. And again, this concept of normalization is also known as horizontal partitioning. So we know normalization by another keyword here. Maybe you'll hear that in future, horizontal partitioning. So we have two type of partitioning in SQL Server. One is the vertical, which is again an advanced concept. We will cover it after 15 classes or so, and second is the horizontal. So right now we just covered the horizontal partition. Why we say this horizontal? Because we are just breaking it apart with the in horizontally. So that's all for today, guys. Let's